Hello, this is an intro video to Chapter 10. In Chapter 10, we are going to start comparing two groups, or we would refer to them as two populations. So in this first video, we're just going to focus on the very first learning target, which is describe the shape, the center, and the spread. Really, we're going to be looking at the socks of the sampling distribution of the difference between the two sampling proportions. As part of the introduction, we again need to talk about what are the populations and what are the variables that describe them. So again, suppose we want to compare the proportions of individuals with a certain characteristic in population 1 and population 2. Basically, it means we have two groups, and for example, if you're thinking of two classrooms and you want to compare proportions of girls in each of those two classrooms. Again, let's call these parameters of interest P1 and P2. When we don't have hats on them, we are referring to them again as the population parameter. And so that's about all of the people in the room. And again, think of them as being very large rooms. The ideal strategy is to take and separate the random groups from each population and compare the sample proportions with that characteristic. So again, instead of maybe talking about proportions of males or females, maybe we want to talk about the effectiveness of a treatment on two groups. So if we want to compare the effectiveness of a treatment 1 and treatment 2 in a completely randomized experiment, this time the parameters are P1 and P2 that we want to compare and the true proportions of success that for each treatment. So again, just changing the specifics or changing the situation. And we use the proportions of successes in each of the two treatment groups to compare. So again, if you have two different treatment groups, you have a proportion of the whole entire group that had successful results. A statistic is maybe we only again sampled 50 out of our group or each group, and this p hat is the proportion that were successful out of the 50, and because I said the number 50, that is your sample size, that is your n. So they're the same variables that we've been studying, and you should know at this time what all the variables represent. So to explore the sampling distribution, again the socks of the difference between two proportions, let's start with two populations that we know with a known proportion of success. So for example, two populations, school 1, school 2, 70% of the students at school 1 did their homework last night, 50% of the students at school 2 did their homework. Suppose the counselor at school 1 takes a simple random sample of 100 students and records the sample proportion that did their homework, and then the same thing happened at school 2. They take instead though a 200 simple random sample and records that proportion. So the question is, what can we say about the differences between now our statistics? Again, we know that they're different sizes, but now we want to know what can we talk about as their difference in the proportions. So the first thing we're going to do is look at some graphs. So this was again school 1, and I know that because it says p hat 1. And it talks about the shape. The shape is approximately normal. It talks about the center. The center of all of your statistics is always your parameter. So 0.7, and I believe we learned that in chapter 7 or 8. The spread that we've learned about is, again, standard deviation of p hat 1 is the square root of p1, that's our parameter, minus 1 minus P1 divided by n. And so again, they told us that 70% of the students at school 1 did their homework, times 30% divided by 100, and that is our spread. So now we have sort of our distribution for school 1. School 2, they asked 200 students, or took a simple random sample of 200 students. Again, found it to be normal. Found the center, which is what they told us happened at the school. And then they once again found the spread like we did in chapter 7. So all of the information in these two tables is something that we learned in Chapter 7. The stuff that is new is, as we're looking at Part C, what's the sampling distribution of their difference? Again, the shape will not change. If the two individual sampling distributions are normal, then their difference will be approximately normal. Their center then would be the difference between the two centers. So 70 minus 50 is 20%. And their spread is the difference between the two spreads. Now, when you think about the difference, it's not that I'm subtracting. We again are using rules from Chapter 7, where if we want to find the sum or the difference of standard deviations, you have to add their variances and square root. So it's starting to put together a lot of things from the end of first semester and the beginning of second semester. And again, we were just describing the socks, the shape, the center, and spread about the difference. That's the new piece today. A and B should be review from earlier. So again, just kind of going through what are we looking for? We're looking for, again, the shape. How do we prove it's normal? That's actually our large counts conditions where we did NP and then N times 1 minus P. But we have to do it for both groups or both populations, and we want them greater than 10. The center is just the difference between your parameters. That's from Chapter 7. And then the spread, again, add together the variances and take the square root. And so that's how they were able to find the difference, the standard deviation or the spread of their difference. Again, it does have to still fit in that 10% condition as well. So this is kind of what a graph would be describing. And when you have your graph describing it again, it's the distribution of their difference. Your standard deviation is how far away is it to the point of inflection. And then obviously your mean is still in the middle. So let's just briefly look at an example in here, and then we're going to do question 1A from your worksheet. So again, now we're doing kind of similar things. Suppose that there are two large high schools, each with more than 2,000 students in a certain town. Again, at high school 1, 70% did their homework. Only 50% did their homework at school 2. And the counselor at school 1, again, takes the simple random sample. So exactly the same scenario that we were looking at before, but now they're going to show you the work, not just the picture from the graph. So how were they able, again, to say that it was normal? They took the sample size from school 1 times the proportion, greater than 10. Sample size times the complement, greater than 10. Did the same thing for school 2, greater than 10, greater than 10. We know that it's approximately normal. Again, how did they show the mean? They just said show the two parameters being subtracted. And then how did they find that standard deviation? Add together the two variances. So what I'd like to do now is I'd like to do a brand new example, again, from your worksheet. This will be question number 1A. So take a minute to get out your worksheet. So now let's look at question 1. It says you have two large bins of several thousand plastic beads. Bin A is 60% red. Bin B is 48% red. Suppose you take a random sample of 80 beads from each bin and calculate, here's a statistic, P hat A, the proportion of red beads in the sample from bin A, and P hat B, the proportion of red beads from sample B. And if you look at the question is describe the sampling distribution. So again, whenever they ask you to describe the sampling distribution, you are describing the socks. Now, there won't be any outliers in this case, but we're going to start with shape. So in order to figure out shape, we just saw that we have to show that it's approximately normal. So what we're going to have to do is we're going to have to multiply the sample size from bin A times the proportion of red beads from bin A. So again, that would be 80 beads taken out of bin A, and they said that 60% of them are red, and we want to know, is that greater than or equal to 10? And yes, that would be. Then you do the same thing with, again, the sample size from bin A times 1 minus again, that proportion, so 80 times 40, and is that greater than or equal to 10? And the answer is yes. You have to do the same thing for bin B and figure out if you took 80 out of bin B and multiplied that times 48, is that greater than 10? And again, you have to do the complement from bin B. If you took 80 beads out and multiplied by the complement, is that greater than or equal to 10? Because all of these are greater than or equal to 10, what you get to talk about is that, again, the sampling distribution is approximately normal. So the sampling distribution, just as it's listed in the question, of p hat A minus p hat B is approximately normal. But you have to show now 4 steps instead of just 2 of them. The next one is to do our center. Again, our center is pretty straightforward. If you want to know the mean of p hat A and p hat B minus p hat B, then you're just taking the parameters. Again, that would be 60% were read out of bin A and 48% were read out of bin B, and you're just subtracting them. So the center, or the mean again is written this way, the mean is 12%. There is a 12% difference. And then the last one is the spread. If you want to know the spread, the standard deviation of, again, bin A from bin B, you have to take the square root of the sum of their variances. So again, if you're looking at the formula, this is what the formula would look like. There's the variance for bin A. This would be the variance for bin B, and then you take the square root. So in ours, this is 60% times 40%. We took out 80 beads plus 48 times 52, and we took out 80 beads from bin B. And then it's just a matter of plugging that into your calculator. When I plugged it into my calculator, I got 0.0782. So that is the spread of my difference for the two. But again, whenever we calculate standard deviation, this is where that condition, your 10% condition, was listed. As long as the population is 10 times your sample, again, in each bin. Because we're dealing with 2 different populations, so this would be NB and this is NA, you have to make sure that it's at least 10% of each bin. So this is the 10% condition, 10% of each bin. So this first video, again, was just describing for you the sampling distribution. How do you find the shape, the center, and the spread from a proportion question? The next few videos will show you how to do confidence intervals and significance tests.